Hi everybody, and welcome to lesson 2 of our trigonometry unit. Just a quick review from last lesson. We learned the three ratios of trigonometry: sine, cosine, and tan, and there was this nice abbreviation, SOHCAHTOA, that helped us remember those three ratios. And specifically, sine, the sine ratio is the opposite side divided by the hypotenuse. The cosine is adjacent divided by the hypotenuse. And the tangent is the opposite side divided by the adjacent side. Remember, this is all with respect to where your angle is. And obviously, if your angle is here, then the opposite side would be this one, and the adjacent side would be this one over here. The hypotenuse side is the only one that doesn't really change. On the other hand, if your angle was measured here, let's call it x, then or we can just call it 45 degrees, this would be the opposite side, and this would be the adjacent side. Okay, the hypotenuse is the only one that doesn't change. Hypotenuse is always the long side. Okay, so try and memorize those three ratios. Things you can do questions much quicker than having to look them up. Okay. Let's before we jump into this lesson, let's kind of remind ourselves of what we're doing here and why we're using trigonometry. Again, remember that trigonometry only works for angles that are right angles, so 90-degree angles here. And what we're saying here is that for example, look at this question down here. For an angle of 35 degrees, our ratio of AB, which is the opposite, over OA, so this over here, this ratio here, that would be the tan ratio. So tan 35 would be the opposite over adjacent. And what we're saying here is that there's only one possible value for that angle of 35. There's only one possible ratio, and that is 0.7, or that's 7 over 10, or that could be 14 over 20, or any other ratio that works. And what we're saying here is that the length of the opposite side, I'll write it in green here, is would be, for example, it could be 7 and this could be 10, or it could be 14 and this would have to be 20, and so on. Okay, the point is that the ratio never changes. It's always 0.7. In other words, if we were to increase this angle to, let's say, 40 degrees, that would look something like this here. That would be 40 degrees. And if we would have to redraw our line over here like this, all of a sudden, what happens is the opposite side got larger, but the adjacent side stayed the same, so our tan ratio would get bigger, because this would no longer be 7 over 10. It might now be, I don't know, it could be anything, it could be 9. I'm just using random numbers here. But this would still be 10, so now it's 9 over 10. Now it would be 0.9. Now I'm just making that up. That might not be the actual ratio. The point here is that every specific angle has a specific ratio. For example, the angle 58 degrees has a ratio of 1.6. Okay, in other words, this could be 16 and this could be 10. Or again, this could be 32 and this could be 20. As long as we maintain the ratio of 1.6, we're okay. All right, on that note, let's jump into lesson 2, and hopefully this will make more sense here. All right, we have, obviously we have calculators today, but back in the day when they didn't have calculators, you were given a trigonometric table, and on that table would have been all these ratios. In other words, tan 35, you would look it up on a table and it would say 0.7. Tan 36, it might be something else. Tan 37, it might be something else. You'd have to measure all the lines and then divide them to get the actual ratios. Luckily, our calculators will do this for us, so we don't have to, we're no longer using a table, and we can get much more precise answers. Okay, so let's I'm just going to skip this section. You can go ahead and do this one at home. Okay, I'm going to jump right into example number 1. Okay, the first question says use a calculator to determine the value of each ratio to 4 decimal places. Well, sine 35. Okay, sine 35. If we were to draw a little triangle here, like this, sine 35, and I'll put the 35 over here. Sine 35 would be opposite over hypotenuse. So what this is telling us is the ratio of opposite over hypotenuse. And there's only one possible value. I think that corresponds to this over here, angle 35. Let me just erase all this so you get a nice picture here from the beginning. Let me get all of this. There we go. So if I were to look at sine 35, I'd now be looking at opposite here over hypotenuse, which is this one, and that would be a different ratio than 0.7 because we're looking at the sine ratio, not the tangent. Okay, so let's go ahead and figure that out. Now, again, we would need a table if we didn't have a calculator, but luckily our calculators will do this for us. So there's our sine button here, and make sure you go to mode here, and then go down to radians here, and just scroll over to degrees and hit enter, and make sure your calculator is in degree mode. Okay, now we're gonna so second function, quit to get out of there, and now we're just gonna hit sine 35, and there's a ratio. Okay, it's gonna give you multiple decimal places here, and so we want, what does the question say? I think 4 decimal places, so 0.5736. 0.5736, I believe. 0.5736. Okay, if we were to do this to let's say 2 decimal places, it might be we'll just might round it off to 0.57, and what this is saying is that the ratio of the opposite side to the hypotenuse is 0.57, and of course this is over 1. So if I were to draw a diagram, or let's go back to the previous diagram because that's the same angle here. What they're saying is that if this, for example, was 57, the length of AB, then this would be 100. Okay, that would be that ratio right there. Okay, let's look at cosine 35. Cosine 35. We're gonna get a calculator out, so we'll go cos 35. Hit enter, and 0.8192. 0.8192 is that ratio. Sine 58. It's pretty straightforward. The questions aren't that hard. Sine 58 is 0.8480. So again, the math is not very hard. The point is you have to understand what it is that you're getting. What do these numbers mean? And again, this is the most important thing, is that that is a ratio of the, in this case, the opposite over the hypotenuse. In this case would be the adjacent over the hypotenuse, and so on. Let me show you a little trick with the calculator. If I were to just make this to 2 decimal places, I can go 0.85, that would be 2 decimal places, and then I hit enter, and if I go math and I hit fraction, it'll turn that decimal into a fraction, so 17 over 20. So you can get an actual example of the length of the 2 sides. All right, cos 58 is the final one. Cos 58, 5299, so 5299, 0.5299 is the last one. So with respect to the diagrams at the top of the page, which ratio of sides is represented by each of the ratios in A? Well, with this would be the sine ratio. The sine ratio would be AB over OB. That's the sine. That's sine 35. And cosine 35 would be adjacent, so it would be OA over OB. And then in this case, we would have, let me scroll over here. In this case, we would have sine 58 degrees would be opposite over hypotenuse. So that would be AB over OB, and cos 58 would be adjacent, which is OA over OB. All right, let's move on here. Speed things up a little bit now that we got the hang of what we're doing. So let's jump to this example. So in the diagram below shows a triangle similar to the ones on the previous page in which two hypotenuse are equal to 1. Okay, so if the hypotenuse equals to 1, then we want to fill in the other ratios, and if that was 1, 0.5736, 0.5736, that would be that one, and this cosine 35 would be 0.8192, 8192. Those would be, so if the hypotenuse was 1, the length of these two would be these decimal numbers here. And I guess that makes sense, because this looks to be about half of this, and that is about half of 1, so kind of makes sense. Okay, so let's look at this next question, number 2 here. As the angle AOB, so this angle here increases from 35 to 58. Okay, so now it increases from 35 to 50. Explain using SOHCAHTOA why the sine ratio increases in value but the cosine ratio decreases. Okay, so let's explain this. What's happening here? Why does the sine ratio increase? Well, the simple reason is, look at the sine ratio here. The sine ratio is let me write it out. Sine 35 is opposite over hypotenuse, which is 0.5736 over 1, we can say, hypotenuse. And in this case, sine 58 is sine 58 was 8480, I believe, and again that would be over 1. So why did the sine ratio grow as the angle increased from 35 degrees to 58 degrees? Well, the simple answer is that the hypotenuse never changed. Its length remained at 1, but what happened was the adjacent side shrunk, and the opposite side kept getting larger. So in other words, as the opposite side gets bigger and bigger, your ratio is gonna get bigger and bigger. Eventually, let's say, if we do another example here, let's say I do another example where, well, let me do another, even a more extreme example. For what if I had an angle that was like really steep like this? It's gonna be hard to draw this one like that, and there's my right angle there, and this was 1, that's the hypotenuse, and this angle was close to 90 as well, so maybe it's, let's say, 85. Well, this now, you can tell that this now, the length of the opposite side is getting closer and closer to 1. So eventually, your ratio is going to be 1 if you get to 90 degrees, and then you wouldn't even have a triangle anymore. The point is that you can never have more than 1, because the opposite side could never be larger than the hypotenuse. All right, let's move on. Okay, without using a calculator, these questions are actually really good because they force you to visualize the triangles, and if you can't visualize them yet, you might want to draw them out on the side here. So without using a calculator, state which of the following ratios has a greater value, sine 14 or sine 20. Well, I'll do the diagram for the first couple, then hopefully we can all start visualizing this. So if I have a triangle here, so that would be 14 degrees, and then I have another triangle, a little bit bigger angle here, 20 degrees. Well, and the sine ratio is opposite over hypotenuse, which of those is going to be bigger? Well, the bigger the angle, the bigger this side is over here. If I want to have a bigger angle, let's say 50, then it's going to look like that, even bigger. So sine 20 is going to have a greater ratio, okay, as long as obviously our hypotenuse stays at 1. Okay, this diagram is not really drawn to scale here. Okay, let's do cosine 7 versus cosine 62. Okay, so cosine, let's again draw a quick diagram. There's 7 degrees. Now that's not a very good 7 degrees. I'll make that one. Let me just do it more realistic here. So 7 degrees is really flat like that. So 7 degrees versus 62 degrees. 62 degrees is going to be more like this. 62 degrees. Okay, now cosine is adjacent over hypotenuse. So which one is going to be more if the hypotenuse equals 1? If the hypotenuse equals 1, which ratio is going to be bigger? Well, the cosine 7 is clearly going to be bigger because that is almost, the adjacent side is almost as long as the hypotenuse itself. Here it's much shorter. Okay, so the cosine 7 is going to have a bigger ratio. Tan 15 versus tan 75. Tan 75 is going to have a bigger ratio. You can draw the triangle yourself and check. Sine 80, cosine 80, or tan 80. Okay, this one might be a little bit tricky to visualize. Let's draw it out. Well, I'm going to cross this one out. I know that one's not going to be it. But sine 80 is nearly vertical, even more so than that. Let me do another one. It's going to be, there's my right angle, and that's going to be approximately 80 degrees right there in the corner. So if that's 1, this is going to be, this is going to be close to 1 right there, and this is going to be tiny. That's why I eliminated the cosine right away. And if this is really small, if this is 1, this is going to be very small. So this ratio is going to be much bigger, the tan 80, because tan is opposite. Well, sine 80 is opposite over hypotenuse, while tan 80 is opposite over adjacent. So opposite over hypotenuse, it can't be bigger than 1, obviously. However, this one is going to be much larger than 1 because the opposite side is 1, and this is going to be maybe like 0.1 or something, 0.1, which would make that 10. Okay, I'm making this number up here, but just so you get the visual. All right. The trigonometric ratios for all angles between 0 and 90 can be approximated using a calculator. Great. Okay, so use a calculator to determine the value of each of the trig ratios to 4 decimal places. So very similar to what we did earlier. So sine 81, 0.9877. So again, very close to 1 there. Tan 14. I'm going to skip these. You guys can go ahead and do these yourselves just on the calculator. Okay, let's do this last bit, and if you're tired of watching this video, unfortunately this is the most important part here, because now we have to we're going to be working backwards here. We're actually going to figure out the angle from a ratio. So now we're going to be given a ratio, and we're going to be able to calculate the angle. I'm going to try and go a little bit quicker here just to save some time. But basically, if we looked at this question here, we know that tan 35 equals 0.7. Let's go ahead and double check that. Tan 35, so tan of 35 degrees is 0.7, or more or less 0.7. Well, what if we don't know the ratio, the angle, and for example, we're given a triangle like this, and it tells us that this is 7 centimeters, and this is 10 centimeters, and the question says, what is the angle? This could be x, so, what is the angle there? Well, working backwards, there's only one angle that's going to be associated with this ratio, so we can go tan x equals 7 over 10, and now we just work backwards, just like solving any algebraic equation. We have to get x by itself, so we're going to get the tan on the other side. How do we get the tan on the other side? That's the new part that you're going to learn right now, and your calculator does the hard work, but basically what you're doing is taking the opposite of tan, and the opposite of tan is tan inverse tan, which is designated by a little -1 up top there, 7/10. So just like we do solving any equation, we always do the opposite. So the opposite of squaring is square rooting, the opposite of multiplying is dividing, the opposite of tan is inverse tan, the opposite of sine is inverse sine, and the opposite of cosine is inverse cos. So your calculator does the work here for you, and we're going to hit, so right above tan here is the inverse tan, so hit inverse tan, and we're going to hit 0.7 or 7 divided by 10, whatever you like, 7 divided by 10. And we should get close to 35. There it is, 34.99. So there we go. So 30, we'll just round that up to the first degree. Let's do a couple more, and then this just tells you how to do it in your calculator. So here's the ratio, that's over 1. Sine, we're looking for the angle, sine A, so we need to go A equals sine, inverse sine, 0.3584. Inverse sine, and punch that in, 0.3584, and you got your angle, 21 degrees. And you know, I'm going to let you guys go ahead and finish this off. I think everybody can handle putting the inverse functions in your calculator. So inverse cos would just be here, inverse cosine, inverse sine would be here, and so on. All right, thanks for watching, and see you guys in class.